Alright, now we're going to look at a solved example on network constraints. So here we have a network that we're going to fill, we're going to solve, and we're going to fill this table with the dates, noticing that this network has three constraints. One of them is a start no earlier than constraint on activity E, start no earlier than day 28, and one is start on day 33 on activity I, and the third one is finish no earlier than, this is a start no later than day 28, this is start on, and this is finish no earlier than day 49 for activity J. So let's go ahead and start solving this network. Here are the durations for the different activities. We're going to start with activity A. It's going to start on day 0 with a duration of 8, so its early finish is day 8. Activity B, no lag, no overlap, is going to start on day 8, and duration 10 days is going to finish on day 18. Activity C, again, no lags, no overlaps, is going to start on day 8 again, and is going to end on day 23. So far it's very straightforward, very simple. For activity D, we had a finish to finish relationship with a lag of 9 days. So it's going to finish 9 days after the completion of B. B ends on day 18, so D is going to end on day 27. Assuming contiguous duration, it's going to start on day 20, which is 7 days earlier because the duration is 7. Now going to activity E, from C we have no lag, no overlap, finish to start. So from C we have day 23. What should we put at the start of E? The constraint says start no later than day 28. So what should we put here, 23 or 28? First of all, this is a late date constraint, so it does not have any effect whatsoever in the forward pass. So in the forward pass, as if it does not exist, because the left side of the triangle is white, is not shaded. So we're going to follow the calculations. Therefore, we're going to have 23 for the start of activity E. Its duration is 16 days, so it's going to finish on day 39. Activity F starts 13 days after the start of C. C started on day 8, so F is going to start 13 days later on day 21. Duration 10 days, so it's going to finish on day 31. As you can see, very simple calculations and very straightforward so far. Now moving to activity G, finish to start with D. D ends on day 27, so G is going to start on 27. 9 days of duration, therefore is going to finish on day 36. Activity H, we have two numbers. The number coming from E was, the early finish for E is 39. So 39, and the duration of H is 17, so it should finish on day 50. But from D we have 27 minus 3, which would be 24. So we're going to take the larger number, of course, because we're moving in the forward pass. Therefore E is going to be driving H, so we're going to have from E 39 plus a duration of E was 39, duration of 17 days, so that's 56. Notice that activity is open-ended. It does not have any relationship to any other activities later on. Now going to activity I. Activity I has an on constraint. Start on day 33. So immediately, even without looking at any numbers coming from any other activity, we're going to plug in 33 here and here as well. Because again, this is start no earlier than, start no later than, which means start on 33. So we put early start 33 and late start is 33 as well. And that's going to create a critical point here in activity I. Now going to activity J, and if it starts on day 33, it has a duration of 11 days, so it's going to finish, the early finish is going to be day 44. Going to activity J, finish to start with G, so we have no lags, no overlaps, so 36. The duration is 13. It says finish no earlier than day 49, which is exactly the date that comes from the calculations. So there's no conflict between the calculations and the constraint, therefore the calculations still hold, so we're going to put here 49. And finally, activity K, we have two numbers coming to K. We have either from the start we have 49 coming from J, or from the finish we have 44 plus 12, which is 56, coming to the end of K. The duration of K is 8 days, so 49 plus 8 is 57, which is going to be larger than the number coming from I, so J is going to be driving activity K. So here we're going to put 49 and 57, and that's our forward pass. Now we're going to put 57 as the late finish of activity. Oops, that's not the proper location. We're going to put late finish of activity K as 57. Let's just change the color here. So 57, and going backwards the duration is 8, so the late start is going to be 49. So obviously activity K, as we can see, is going to be critical, so we're going to just mark it as critical. Okay, and if it's critical, total float is 0 and free float is 0. Now going back to activity J. Activity J is the one that drove activity I, so most likely, as we can see, the longest path is going to be here at the top. Activity J is going to be critical as well. So here we have 49 minus 13, that's 36. So this again is a critical activity. And a critical activity is 0 total float, 0 free float. Going to activity G, I'm just skipping the other ones here for a second. Activity G is going to be 36. Oops, not the right cell. 36 and 27. So again, this is going to be critical. And 0 and 0 as total and free floats. Going to activity D, again we can imagine that the critical path is going to go through D and B and A. So D is going to be 27 and 20, 0 and 0, and here is going to be critical as well. Activity B, we have 20 here, 20 minus 9. No, we have 27 at the end. 27 minus 9 is going to give us 18. And 8. And 0 and 0 for the total and free floats. And again, B is critical. And finally, A is going to be basically 8 and 0. And here we have 0 and 0. And again, A is going to be critical as well. So these are my critical activities. Now let's solve the rest of the network. Now we have to go to activity H. Activity H has no immediate successors, therefore its completion is not tied to anything, so it's going to have the total project completion as its completion as well. So the late finish for activity H is going to be day 57, which is the completion of the project. And if it's 57 minus 17, that's going to give us 40 here. Now just to make sure, let's look at activity D, because H was a successor to D. So if we have here 57 minus negative 3, that would be 60, but from G we have 27, so what we did was right. D is going to be critical. Now let's look at the total and free floats for activity H. It has a total float of 1, 57 minus 56. And since it does not have any other successors, the free float is going to be the same thing. Now looking at activity E. From H we have at the start, late start 40, so we're going to have here 40. And in the backward pass the duration is 16. And here it says start no later than day 28. From the calculations, 40 minus 16 is going to give us 24. The question now is, does that have any conflict with the constraint? It says start no later than 28, and obviously 24 is not later than 28, so the constraint here has no effect on the calculations. And now looking at the total and free floats, again the total float is going to be 1. Free float for this activity is going to be the total float minus the total float of the immediate successor, which is H, which has a total float of 1, therefore the free float is going to be 0. Now going to activity I. Activity I, here we have at the end 57 minus 12, which gives 45. So for activity I, it's going to be 45. Question now, what is the total float of activity I? From the start, it's 33 minus 33, so it's 0. But from the finish, it's 45 minus 44, so it's 1. Therefore, this activity has two total floats. From the start, it's 0 because it's half critical, and from the finish, it's 1 day because it can still be delayed by 1 day without delaying the whole project. Now what about the free float? We're going to measure it from the end, so it's going to be, in this case, 1 day, because its immediate successor is critical. Very well. Activity F. Here we're going to have 33 as the late finish coming from I. 33 minus the duration of F, which is 10, so we're going to have here 23. Let's look again at the total float. Basically it's 23 minus 21, or 33 minus 31, so it's 2 days. What about the free float? Well, the following activity is critical from its beginning, so here we're going to have 2 days of free float as well. And finally, looking at activity C, from E we have, on the way back, we have 23. From F we have 21, so we have 23 here at the end, and the duration of C is 15, so we're going to have 8 at the beginning, coming from, let's write these numbers. From E we have 23 minus the duration, which is 15, so the early start of activity C coming from E is going to be 23 minus 15, which is 8. Looking at the numbers coming from F we have the finish, the start of F, late start of F was 21 minus 13, so it's going to give 8. So in both cases it's going to be 8, therefore we don't have any problem. So here we're going to have 8, and the duration for C is 15, so it is 23. Very interesting here. Again, what about activity? Let's just make sure that these numbers are correct. So here at E we had late start 24. Oh, 24, not 23. So 24 minus 15, that would be 9. And from F it would be again 33 and 23. 23 minus 13, it would be 10. So we have 10 coming from F, and we have 9 coming from E, therefore it's going to be 9. And 24. Looking at the total float for activity C is going to be 1 day. Free float for E was also 1 day, therefore the total float for E is 1 day, therefore the free float for C is 0. And here's our network with all the calculations. Here are the critical activities, and we have a half critical activity here in I, which is something that we haven't seen before, and that's all because of this constraint. I hope this example helps you understand how the constraints work when they are in effect. I would like you to try to solve this problem again without looking at our answer. Just copy the problem and try solving it on your own, and then compare your answers to the one that you have here in this presentation. I'll see you in another class.